So here we are asked to solve this system of equations with three variables. So I have a bunch of steps here on the right, and I'm going to do my best to make it neat enough and clean enough to do on one page, but we'll see how that goes. So first thing that I'm going to do, and again, if you've seen previous videos on these problems, for me, I don't want to force you into substitution or elimination, so really just choose what you like on certain steps. Just know that when I use substitution, if you would have used elimination, that's totally fine too, but I'm going to go ahead and show it the way that I like to do it. So I'm going to start by using substitution. So what I'm going to see here is I'm going to first find a variable that I want to plug in here, and I'm going to solve for that and get the variable by itself. So in this one here, I guess I can go ahead and start with x here. I'm going to have x equals negative y minus z plus 9. So again, I'm just moving all of this stuff over here to the right side so that I can get the variable alone. That's the first step. That's all there is to it, getting a variable alone. My second step is I want to substitute this. So I'm going to plug all of this into one of my equations here and then distribute and simplify. So I'm really going to be doing two steps here in one, but I'll first plug it in. So wherever I see x, okay, it's just in the very beginning. I'm going to go ahead and say negative y minus z plus 9, and then I'm going to put the rest of the equation into there. So minus 8y minus z equals negative 27. So there's step 2. I'm going to continue with step 3 by distributing and simplifying. So what I'm going to do here is I'm going to combine like terms. I have a negative z, negative 8y, and a negative y. So I'm going to have negative 9y minus 2z, and then I'm actually going to move this negative 9 over to get negative 31. Nope, sorry, negative 36. And now that I have two variables, I am done simplifying this here. I'm just going to leave this be. So now I'm going to go ahead and I'm going to repeat these steps. I'm going to substitute again, but instead I'm going to substitute into my second equation. So what that'll look like is I have 2 times x, which is all of this, minus y plus z equals 6. So again, I'm doing step 2 again and step 3 to distribute and simplify. So distributing this 2 to get negative 2y minus 2z plus 18 minus y plus z equals 6. Now I'm going to combine like terms. Looks like I have negative y and negative 2y to get negative 3y. I have negative 2z and positive z to get just negative 1z. And then I'm going to subtract 18 from both sides. And that's going to give me, ignore my little scribble there, negative 12. And there is our second equation. Now that we have two equations with two variables, I'm going to move on to my next step, step 4 here, because I know how to solve when I have two variables and two equations. I'm going to do the same thing. In this case here, I'll go ahead and simplify. So what I'm going to do is I'm going to add z to both sides and then add 12 to both sides of this one. Again, I'm just rearranging this so I can solve for one variable. So I get negative 3y plus 12. And now I can use this to substitute into my other equation that's all the way up here. I'm going to do that to the right. So I leave negative 9y. Now I'm going to plug in z into here, which is from my equation negative 3y plus 12. Oops, running out of room here. And then all of that is equal to negative 36. So sorry about that. It's over here. Again, like I said, trying to keep this neat, but a lot of steps and not a lot of room here. So then I'm going to distribute and make this look a little bit prettier for us. So we're going to have negative 9y, and then negative 2 times negative 3 is positive 6, y. Negative 2 times positive 12 is negative 24. And then all of that is equal to negative 36. Now I have an equation with just y values, so I'm going to combine like terms and solve for y. So combining like terms, I get negative 3y minus 24 equals negative 36. Now I'm going to add 24 to both sides. Divide both sides by negative 3 to give me y is equal to 4. Now I am done here with step 4, and now I'm going to go ahead and plug this value back in to what I solved for here, because that is going to tell me what z is equal to. So I'm going to have negative 3 times 4 plus 12 equals z. Negative 3 times 4 is negative 12 plus 12 equals z. And negative 12 plus positive 12 is just 0. So boom, we got z is equal to 0. And now my final step here is plugging these back in. So I'm going to plug in y, which is what I know, and z. And I'm going to plug those back into my equation all the way back from step 1, which is this one up here, if you remember this guy. So I'm plugging that in. X equals negative y, which is 4, minus z, which is 0, plus 9. Negative 4 minus 0 is just negative 4. Plus 9 is going to be positive 5. Now let's say you do this problem and you still have some extra time to spare, which I understand if you don't because of how long these take. But if you want to double check your work, plug all 3 of these back into one of our equations and make sure that it gives us a true answer. If it does, then we can check it off and say, yes, we know we're correct. Also, we talk about ordered triples, and we usually write it kind of like a coordinate, but since there's 3 of them, you'll see the x value is first, then the y value, then the z value.